Okay, ladies and gentlemen, the first thing that we notice here when we're starting in this section, which is 5.1, there's a really weird definition given at the beginning, and it says this is called a polynomial function, and there's a bunch of letters and subscripts and superscripts. That's a little bit over the top for 1033. For those of you going on into college algebra, that kind of formality is going to be important later. But instead of worrying so much about that weirdly written definition, I'm pointing to a function right now. This is what section 5.1 is all about. Polynomial functions. And the function that I'm pointing to right now with my cursor is a polynomial, opposite of x cubed minus 5x plus 6. This polynomial is called a trinomial, obviously because it has 3 terms. And this polynomial is also a polynomial of degree 3. And the way you determine the degree of a polynomial is you look at all of the exponents on the variable, and the highest one is called the degree. So it's sort of like playing King of the Hill. The biggest one wins, okay? Now, the first question says find f of negative 2. Well, what that's telling us in English is negative 2 is my input. So that's basically like what I'm putting in the post office box. So I put negative 2 into the function in place of x. Which function do I use? F, because it says f of negative 2. Now in this situation it may look stupid because there were no other functions written on this page, but there may be times that you have 5 functions. Well, I need to specify which one to plug into. But anyhow, when you're finding f of negative 2, you go to the function, opposite of x cubed minus 5x plus 6, and every place you see an x, you replace it with a negative 2. Notice that when I replaced it with a negative 2, I put parens around it, and I suggest this, especially to you going on to college algebra. When you're plugging into a function, you need to make sure that what you're substituting in, you're being very careful to not mess up the arithmetic. And the best way to do that is to put your input in little safety nets or parens. So look what happens. Negative 2 quantity q becomes negative 8, but then the minus in front, the opposite of negative 8, becomes a positive. And then of course negative 5 times negative 2 is 10, plus 6, so when we add this all up we get 24. So the correct answer is 24. F of negative 2 is equal to 24. Okay, there's that problem. So you need to know, if I give you a polynomial function, you need to know how to plug into it or how to evaluate it. Now, one of the other things you need to know in this unit, and I'm scrolling down here a little bit for you. Oops, I went too far. There we go. Let me come back up a little bit. Okay, what I've drawn for you next is I've drawn a picture of a graph, and I've called this function g of x. But what I haven't done is I haven't given you the rule. Like, I have not said what g of x is equal to. I've given you g of x as a picture, but I've still asked you to evaluate it. I've said find g of 0, find g of 3, find g of negative 2. Well, you're going to read your information directly from the graph. Now, before we get started with that, let's answer this question. Is g of x linear? What that means is, when I ask you if a function is linear, what it should mean is its graph looks like a straight line. So if you know the definition of linear, that's crazy here. G of x isn't anywhere close to linear because the function has a valley in it and a hill in it, and there's no way that's a line. So no, it is non-linear. Okay, when I say find g of 0, 0 is the input. That means it's an x value. I go to my x-axis and I find 0. Now what I do is I now either look up or down until I run into the graph. And in this particular case, notice I'm standing on 0. The graph is above me, so I look up. And when I look up, notice where the graph stops. The y value where it stops is 3. That's why g of 0 is 3. Okay, g of 3, what's that equal to? Well, 3 is an x value. so I find it on the x-axis. When I look at the x-axis and I find the number 3, I don't need to go up or down at all because my graph is already there. I'm already touching my graph. And what that means is if I'm already touching my graph, I didn't have to go up or down at all. My y value is 0. I didn't go up, I didn't go down. So my y value stays neutral at 0. Last question. G of negative 2. We come over to the graph. We find negative 2 on the x-axis. If I look up, I don't see anything. So that means I have to look down. And when I look down, notice where I touch the graph. I touch the graph where the y value is at level negative 3. So that's why g of negative 2 is negative 3. Okay. We will continue with more videos, but this is the first one from section 5.1.